Well,
Got it.
All right.
got it. Ho, 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 everybody. It's our holiday edition here.
You're almost there.
Welcome aboard Christmas Day, the 25th of December morning, 2023. I'm Ron Herron, your host for the SBAU Astro Hour. It's time for our 1 hour weekly vlog Monday mornings. We're all grandparents by now, most of us, so we're not putting any usage of stuff we got outside on the sidewalk. So it's the Santa Barbara Astronomical Unit, South Central Coast Longtime Telescope and Astrophysics Club meeting again. And I learn a lot from these guys. I got to tell you, I try to keep as much of it in my brain as possible. And this week is not going to be any different. We're on YouTube live. These programs are being recorded and saved and archived. And this is number 149, episode 149 for December 25th, 2023 through the 31st, which will be Sunday and New Year's Eve. This week, we're going to talk with the gentleman on the screen and the ladies about a cold moon.
And the cat.
Moon that is cold, and a cat with a tail in the middle of everything. Okay. We even have a holiday tree out in space, believe it or not. And
There's a couple.
Huh?
There's a couple of them.
Really? Okay. Can't wait to see it. In fact, they talked about it yesterday on CBS Sunday Morning. The first episode they had about the Webb telescope, and they showed it to us. We're going to check out Uranus. Any planet spinning on its side is worth talking about and checking in with. Do you know Orion's belt has a star cluster around it? I didn't know that. And another comet, plus the Milkometa. What in the world is Milkometa? It's a collision that we're hoping to be gone in time for in a few billion years. And let's go to the group on the screen. President Jerry Wilson, recently reelected with his wife, Pat Forgy. President, it is our webmaster on these events. Thank you, Jerry. We also have, now just joining us. Spanish.
Tim.
Well,
Who is that guy
I
on?
wear my hat, but unfortunately, I couldn't get it to fit.
Was got a little one, or what are you doing there, Tim?
Yeah, it's this little hat. It's like you see without the background.
Tim, try some double sticky tape.
That's all right.
Yeah.
Our
Couldn't get it to
merchandise
fit.
manager is going to
There
get
it
you one.
See
Tim
the little
Crawford.
Santa hat?
Yeah, there
Yeah.
it shows.
There.
All right, we'll see if we get a sixth person with Bruce Murdoch, but that's Tim Crawford, longtime lens and telescope expert and a SBAU member par excellence. He's married to Karen.
And
Jerry
too
is,
big of a
course,
head.
married to Pat, yep. There are the McPartlands. Chuck, who is the outreach coordinator and the newly elected treasurer for the club starting in a week. Pat McPartland, who's also our merchandise manager, in charge of all the events we do. And by golly, the one and only Tom Whittemore.
Morning.
Captain
Hey, Tom, Merry
Pun.
Christmas, everybody.
Yeah, editor of our monthly newsletter, former instructor out at Westmont College, gets us out there for those Friday, third Friday we meet at
Yeah.
Westmont?
Yeah, third Fridays.
Well, if you ever need somebody to greet people, since I don't have a scope, but I'm vice president again, and I don't know why. Nevertheless, I'd love to come out and join you if I can find my way to Westmont College. Listen, before we go to these topics on a Christmas day, let's go to President Jerry's forwarded silly science cartoons, because we always enjoy these and want to share them with you guys, especially today. So here we go. These are sillies. This one I didn't even read, I don't think. What is the name of this girl? Do you know? Whoops, we got the 2001 Space Odyssey. Okay, there it is. It's off my screen. The monolith. Oh no, she says, I have final exams today, but I forgot to go to class all semester. This is like one of my dreams. I don't know anything, she said, but I have to take the test. Oh my God. And then poof, she wakes up. Why am I still having that dream? I'm 49 years old.
Yeah, boy, that's a lot of truth in that.
I know. I have those dreams. About half of them are coming to class. Everybody else is turning in a paper, and I don't have it. I don't even know what the assignment was.
Either I have this one, or I have one where I show up to a lecture in my underwear.
Oh,
Oh,
Mine are, I'm doing the lecture and you're sitting in the audience and you're the guy wearing the underwear. Where did you get this one? Oh boy, I hope it's a telescope.
Yeah, that's a good one.
Wrap the wheels and everything, or is it spray?
That was a lot of wrapping.
All right. You know, these are not the ones you sent this week, Jerry, but that's all right. What
Yeah,
happened?
this
they are.
is.
Oh, this one is, yeah, the
Yeah,
thinker. There's,
this is the one that doing without thinking.
that's right. What's the artist on the thinker? Reuben? No,
Rodin.
Rodin.
Dan. Yeah, there's a copy of it in Stanford.
Oh, is there really?
Oh, Starry Night.
Oh, here we go. A Vincent Van Gogh commentary. De boldly Gogh, where no Van Gogh has gone before.
No man has gone before.
He would have painted some great space pictures. Here's Calvin and Hobbes. This one I have. Talking about infinity. Another one of those make you feel small, put us in our place, and feel insignificant cartoons. Calvin says, you know, if people sat outside and looked at the stars each night, I'll bet they'd live a lot differently. And his tall friend, the tiger, says, well, how so? Well, when you look into infinity, Hobbes, you realize there are more important things than what people do all day. That's rather deep. Okay, here's Santa Claus checking out a star chart. Galaxy science fiction. Is this an actual cover to an old magazine?
Yes, it is.
Yeah.
In the 50s, there were a lot of sci-fi magazines. I was a regular subscriber to Analog Science Fiction and Science Fact. This
Well,
one, you notice that Santa has 4 arms.
Oh, for crying out loud, you're okay.
Look at the price of the magazine, 35 cents.
Yeah.
and he's got a pipe in his hand, and I guess he's an alien Santa Claus. I
Yeah.
never thought
And
about
here
that.
the solar system, good, bad.
What's it say on the
Filing
calendar?
cabinets.
What's it
Yeah.
say on the calendar? Spacelvania Rocketways?
Yeah.
Okay. Interesting. And 2-star charts. Okay. And all the news channels nationally always in their newscasts on Christmas Eve yesterday. I don't know how much of you watched it, but they always have NORAD tracking him.
Right.
down.
Tracking him.
Like they want you to have your kids gathered around to buy all that. Okay. Fun stuff. Oh, here. What is Dork Tower? Is that Dork and Tower?
I don't know.
Well, let's talk about it here. 2 dudes talking outside in the cold. I warn you, this is another one of those Tom Whittemore puns coming your way.
Mhm.
Every year, one says to the other, I kind of get down when the days grow shorter and darker, but not next week. No, sir, next week, the days finally start getting longer again, post-solstice. And then they just sort of look at each other, and he finally said, you know, I take solstice in that fact. Fun. Oh, I like this one. TV talk show, except I don't understand it. You're going to have to explain it. It's a scientist on the hot seat, and somebody in the audience. Obviously, this is some theory or discovery involved. Maybe Schrodinger. I don't know. Far Side cartoon. Guy asked, my question to Professor Zimmerman: if it's true that you felt Professor Dittmar's theory and subsequent paper was totally unsubstantiated and perhaps even vindictive, well, why did you not simply ask to review his data as opposed to putting his cat into a super collider? Schrodinger again?
Passive aggressive scientist.
I thought Schrodinger used a box. We sort of updated and put it in the CERN, right? Okay. And there they are, the grown kids that used to be in the peanut gallery. I like this one. 2 aliens in their UFO with a Santa Claus sighting. I don't know about you, but for the record, I did not see that. Commercial pilots are saying that all the time.
Yeah.
Gets us all in a good mood to talk about dark spaces and voids and new comets and God knows what else. Uranus. But a cold moon, is that really what we're calling it when it gets full? When is it full? Tomorrow, gentlemen and ladies? Where did the ladies go?
They
Yeah,
want
right there.
Okay, putting the cats out.
I think it's full Tuesday tomorrow.
Okay, I believe so. You said that in your talking points.
Yeah.
Okay, so it's cold.
Now,
It's full
because
for
the moon,
Telescope Tuesday.
it's what?
Full for Telescope Tuesday if we have a clear sky, but it doesn't look good.
Yeah. So anyway, this is showing the moon in all its majesty. And because it sheds so much light, it actually sheds more light than is shown in this planetarium software, but a good representation of it. So the faint fuzzies are right out this session this week. So we're just going to look at planets, theories, and star clusters.
Can I ask a question before you shut this down? Are we looking at the obliteration with the phase and fuzz because of the atmosphere, similar to why stars twinkle? If we didn't have an atmosphere, we'd be able to see the stars just as well, wouldn't we?
They'd still have a problem with the moonlight.
Yeah, but it wouldn't be coming at us so intensely from not around the moon. Our moon light gets scattered by our atmosphere and clouds and cities and everything, and it gets bounced. So the whole sky is kind of luminous. But if you were on the moon looking up, you wouldn't see that affecting the whole sky.
Okay.
But your instrument would do some of this, so you couldn't look too close to the moon.
You add in the light pollution of the cities to a full moon, and all we're going to look at is bright stars, right? We're not going to try to find the fuzzy patches. Tim, you were lit up. You were lit up in a yellow frame, and I thought you were talking.
No, there was background noise.
Oh, okay, gotcha.
Yeah, it could be background here. We just got done with our traditional breakfast.
So here, I just had my traditional breakfast for Christmas of chocolate chip cookies.
Here you go.
Somebody brought
This
me.
is the constellation of Auriga, which the moon is technically in just by a teensy weensy bit there right now. And this is what it looks like at 9 o'clock tomorrow night when it's full. And it's near, like I said, Auriga. The brightest star in Auriga is Capella, which is also the brightest star that's close to the North Pole. And right up here in Auriga, there are 3 stars making a triangle up here. And apparently Auriga is a goat in Arabic or Greek or something.
No, he's a chariot driver, and he's holding a goat and 2 kids, two baby goats.
Okay.
Yeah.
And these 3 stars are called the kids, the baby goats up there. And it's a special cluster.
I never knew that.
Okay.
And Capella comes from, I think, Greek for goat.
Yes.
Okay. Yeah, that's the
I
connection.
always thought it was just a charioteer.
Yeah, but he's holding some goats.
Yeah.
Okay.
You know, for a second there, I was trying to compare that to the medical name for the knee, but that's patella with a P.
Patella, yeah.
Remember, this is used in music if you put an A in front of it.
Yeah.
Acapella.
Yeah.
Means off the top of your head.
No,
Yeah.
I've been playing tennis for a few years. Mine's a Capella.
Okay.
So these are the official names of those 3 stars up there near Capella. Almaz, Hadus, and Hadus 2. They're magnitude 3, almost to 4. So they're not as bright as the pole star at magnitude 2, but they are a star cluster. And so then we're going to
go to the
so
planet.
that's our first cluster. Yeah, go ahead.
Well, a couple of asteroids thrown in, and isn't it great that Pluto still gets homage, gets honored?
It's just me that does that.
Oh, is
Nobody
that
else
you're the
does it.
one that put it together? Okay.
Yeah.
Let's go down.
I don't copy this somewhere else. I go thumbing through all sorts of pages looking for this information.
Hey, Jerry, can I make a comment about Capella?
Yeah.
Gemini is near Auriga, and I could never remember how to recognize Castor from Pollux. Well, so therefore Castor is always towards Capella, and then Pollux is always towards Procyon.
Yeah. You can also identify them from color, Tim.
Oh, really? Okay.
Yeah. Pollux is very yellow and Castor's quite blue-white.
Yeah.
And Capella's yellow-white. It's the same. It's a giant star, but it's the same surface temperature as the sun.
But we also have castor oil. No relation.
No, castor, I think, is the word for beaver. Believe it or not.
Yes.
Oil.
Yes.
Yeah.
Then what's Pollux?
Not sure
His
about
brother.
that. His
Yeah,
brother.
his brother.
Beaver's brother.
Well, you've heard of small Pollux.
Beaver's brother. I thought that was Eddie.
Yeah. Leave it
I
to
think we've
Beaver.
been drinking a little eggnog here this morning.
I think he's laced it a little bit. Okay. Let's go back to the planets, Jerry.
Mm-hmm.
And the two honorary asteroids, one of which we've been talking about lately, Metis and Astro.
Last week, yeah.
Okay.
They both reach opposition this week, different days. Metis is 8.5, almost 9 in Gemini, and Astrea is about 9.5 in Gemini. Neither of them are bright. If you know what you're doing, you might pick them up in binoculars. But I think a small telescope and just leave it set there, tracking the sky, of course, and watching the thing move with respect to the background stars is the only way you're going to see these things in a small scope.
Well, forgive me, Mr. President, I got to get this down. Opposition, does that mean it's on the other side of the solar system from
It
us?
means it's opposite the sun in the sky.
Well, it's always opposite the sun, isn't it? What do you mean?
No.
I don't understand.
From our perspective.
From our point of view,
Yeah.
they could be close to the sun, but then you couldn't see them.
Yeah.
Let's
Okay,
put it this way: the Earth is between the sun and the object.
Yeah.
Right.
Oh, so it's sort of behind us. Sun's in front of us, it's in back of us.
Whichever way you're facing, one's one way and the other's the other way.
If it gets to the other side of the sun in its orbit, what is it? What is that called?
Conjunction.
Can we usually see them?
No, they're too close to the sun.
Right.
And too far away. Got it.
It's more in too close to the sun.
Yeah.
And it appears too close to the sun. It doesn't mean that it's closer in actual distance to the sun than the sun.
Okay, I got it. I'm going to keep this
Okay.
one opposition. All right, thank you.
Mercury reached inferior conjunction with the sun last Friday, so that's a poor candidate to try and look at.
Yeah.
Venus is the morning star, rises a few hours before the sun.
Right.
Mars rises just before the sun.
Mhm.
So these are represented here. This is the eastern horizon. And you can see Mars, Mercury, and Venus up here a few hours earlier. And there's, of course, Ceres in there. The asteroid I didn't put in the thing, but it's close to being in conjunction with the sun. And Jupiter is slowly setting in the southwest later in the evening. It's a very nice evening object. Saturn is already starting to set in the south an hour after sunset.
Yeah.
So these are a pair of bright planets. Uranus is in Aries at magnitude 5.7, and we're going to take a JWST look at that in a few minutes here.
Yeah.
And Neptune is in Pisces and sets around midnight. Pluto is in the border between Sagittarius and Capricornus, and therefore sets in the early evening. Sagittarius is one of the very famous summer constellations with the central part of our Milky Way in it. It's not in a convenient place this time. It sets too early for us to look at it in the night.
And there's that cap again, Capricornus for the sea goat.
Mm-hmm. Mm-hmm.
All right, silly
Yeah.
question from the host again. If you lived in the Arctic Circle where it's totally dark 24/7 right now, could you see all these things any time of day you want?
The Arctic Circle is pretty tough because these things are on the ecliptic, and the ecliptic doesn't correspond exactly to the equator. But
Or
it's
the horizon there.
Yeah, we're tilted 23 degrees from it. So if you're up in the Arctic Circle, seeing any planets is quite challenging. You're going to see them way in the south.
Well, they certainly can see.
They certainly what?
Certainly can see Polaris,
Oh
Yeah,
yeah,
it's
that's
straight
right
overhead.
Yeah, right above your head. Yeah.
straight up.
but they don't see anything for the other 6 months of the year, do they? They have a telescope, they just put it away, unless
No, they see the sun and the moon.
Mm-hmm.
Really? Oh, okay.
Sure.
And there are long periods where they have twilight too.
Mm-hmm.
Yeah, it's not a super dark night all the time. It's like half light a lot.
It must be interesting to see the sun just go across the horizon, go around you all day. I can't imagine that.
Now, there's a town, I believe, in Norway or Sweden where it's down in a valley between two mountains, and the sun actually never shines down into that valley. And so they put mirrors up on top of one of the mountains and they shine the sunlight down onto the village in the valley.
Sounds like a science fiction story almost, except not in space. Fantastic.
Yeah, it keeps people from going crazy.
I saw a joke about you know, a country trying to colonize Antarctica, and they figured, hey, if we do farming, then we have a claim that we've settled this place and we can own it. And so they went down to Antarctica and they planted a bunch of sunflowers. And then when it came to summertime, the sun was just going around the horizon and the sunflowers were turning to follow it, and they just drilled themselves into the ground.
That's pretty cute. Yeah. Yeah, that's called heliotropism.
Well, try this question on then for size. Is it possible to put something out there in space above one of the poles, either the North or the South Pole, in a geocentric orbit where it would stay 23,000 miles away, or is that totally impossible? That's only in the...
Because the Earth is rotating. The satellite has to be moving around the Earth. And so it has to hover above the equator is the only place you can do that.
So
They do have things where they want to look, for example, spy satellites have these interesting orbits where you will put it in it's not a synchronous orbit, but it's timed so that it goes, say, over Moscow the same time every day. Goes over there other times too. But you always have a good look at, you know, like an afternoon sun, if there's one place you want to compare activity day to day in.
Otherwise, they're going
Okay.
everywhere. Okay.
This is our Christmas tree thing.
Oh, that's a tree, huh? All right.
It's a
Point it
Christmas
out to-
tree.
All right.
Christmas tree cluster. This is the Cone Nebula up here. And at the top of the tree is down, the tree is down this side, across there, and then back up. And there's the pot that it's sitting in. So there, and there. And you can see the cluster okay. The nebula shown in this photograph is something you would have a lot of trouble seeing at a full moon night. But you can see the cluster very easily.
I think there's a better Christmas tree cluster. Can I do a
Yeah.
green share?
Is
Yeah,
this from
go ahead.
Edgar? This the one from Edgar?
M103. Yeah.
Yeah, M103, I think,
Yeah.
Is it a cluster?
is
There
a
it
better
is.
Christmas cluster.
Well, there you go.
Okay, now where's the tree?
Well, it's upright. In fact, on the last Westmont, Chuck was showing with his refractor and a screen this cluster, and he flipped his camera around so it was upright for everybody to see.
Yeah.
It was pretty
Okay.
cool.
Yeah.
And that's what's got an ornament.
Yeah, there you go.
Yeah.
Got nothing but
Gonna
ornament.
burn down the whole tree, but yeah.
Is that brightest star the tip of the tree?
Mhm.
Up top, yeah, the white one.
That's
Okay.
it, Tim. That's M103, Tim. We
Okay.
showed that. We showed that too. You and I at
Did
Westmont.
we really?
I think so. Chuck
Okay.
definitely did.
And what's the name of this cluster?
Actually, this looks more like a tree than the other one.
It
Yeah.
does, yeah. This is
Yeah.
M103. It's also called the Christmas tree cluster.
Yeah. Okay.
Oh, old Charles Messier named
Well,
it.
I put mine up because it's what Astronomy Magazine claims is the Christmas tree cluster.
And that's the one that NASA just released a bunch of images of, where they showed the nebulosity in green to make it look more like a tree.
Yeah.
Oh,
Okay.
But as far as science knows, the three wise men didn't go finding that in the sky and went looking for you know who in the Middle East. It'd be interesting if we had green dust around it. Wouldn't that be something? This is the original one. Yeah.
Those pictures, the tone green or anything that you see, those are chosen colors. They're not necessarily the right colors.
Yeah, that's true.
Yeah.
Everything from the web is colorized, isn't it? Because we can't
Yeah.
see them.
Everything from space is colorized.
yeah. And Jerry's
Some-
trees are basically opposite in the sky. So this one I think is in Monteciros, right, Chuck?
Yes.
Yeah. So more in the southern part of the sky.
Well, I
And
swear,
M103 is up near
Polaris.
Cassiopeia.
Well, certainly
It's
puts
up
it-
near Cassiopeia, right?
Uh-huh.
Yep, in that ballpark.
Is there a void in the middle of this picture? Seems to be a dearth of stars right about
No,
mid.
this is not a void. This is
No.
a dark nebula that's not illuminated.
Right.
Oh,
The gas down here and the molecular clouds down here are either excited to shine on their own, fluoresce, or they are shine by reflected light.
Mhm.
This one doesn't have any bright stars near it, so it's just there, and it's dark. It just absorbs light from the background, blocks our view.
uh-huh.
But it is not a true void. We will get to voids in a minute.
I
Mhm.
know, I can't wait.
Yeah. Try not to avoid them.
Yeah, I already used that joke.
Okay.
No, that's not a dark nebula in there, Jerry. That's
Yes.
not.
Yeah, it is a dark nebula.
Oh,
Yeah.
okay.
This
It's
is
probably a
dark nebula.
Barnard. It might be even a
Goes
Barnard.
up there. Yeah, it's probably a Barnard, and it's swirling
Okay.
around down here. All
Those-
that. The
stars-
background of stars is pretty uniform. Is that the
And that
variable
looks like-
nebula?
That looks like Hubble's variable nebula.
Yeah, that's what I
Mhm.
thought.
So as many stars.
Oh,
as there
yeah.
are.
Yeah, you're right. You're right. That is it.
Yeah.
So there's a lot of stars we can't see due to these nebulae.
Mhm.
Do you know why the star? I know you guys all know, so it's a rhetorical question. Why the
Me,
variable
yeah.
nebula is variable? It's because there's a star passing through it. And as it lights up different parts of the nebula's apparent shape and brightness changes.
No, I
Huh.
didn't know that. I didn't know that.
Okay. It's like a plane flying through our coastal fog here in Santa Barbara.
Mm.
I think I
lights
told you
blink on
guys
and off.
before that Hubble's variable nebula was the first image that the Hale telescope took.
I think you're right. Yeah, if I remember.
I'll never forget, gentlemen, seeing on Chuck McPartland's laptop connected to his telescope, pink on Orion.
Yeah.
Is that common? Was the pink
Well,
because of the sun?
Most of this bright nebulosity you see here would show pink too.
Yeah.
Well, maybe it's a black and white picture.
No, it isn't, but they just didn't put up the saturation on it.
Yeah.
Is pink the most common? I mean, we talked about green
that's-
a while ago.
That's fluorescing hydrogen. Yeah.
Yeah, the hydrogen alpha line of hydrogen is very, very red. What, 620 nanometers?
Mhm.
Okay.
Oh, okay.
Very
Now,
deep in the.
is oxygen is green or blue? It's green.
Greenish.
Okay.
Greenish. Yeah.
Actually, I think it's steel, but okay.
These are just bare ass atoms in space.
Yeah.
Not connected. They're
Now,
not.
Wow,
molecules.
that's sort of technical.
Okay.
So DSLR cameras, that is digital single lens reflex cameras, they normally block out this particular color of red. And so you have to, if you want to use a camera like that for deep sky photography like this, you need to get the filter replaced with an extended filter that doesn't block the red lines of hydrogen. So it takes a little bit of extra money to get that done, but the camera becomes more sensitive to one of the most common colors in the sky.
But now we all know the Webb uses infrared, which goes through those dust clouds, right? So-
Yeah, it has a better penetration. It's not blocked as much by dust.
Okay. And I guess we had another telescope orbiting earlier that used infrared, and infrared gives us stars
Several.
we never saw before because we didn't know where they were there until the infrared got their waves, right?
Well, the Webb is looking at deeper infrared than we've ever looked before.
Meaning we can't see them.
It will do that only for a short period of time, a few years, before it runs out of cryogen, of helium-4,
Oh, is that right?
to keep the detector cool. After that, the detector's own heat will swamp out the signal it's trying to detect.
Hmm.
Oh,
That's amazing. Look at those galaxies.
Yeah.
So this is a Hubble image in the near IR.
The Webb.
That's the Webb. That's James
Excuse
Webb.
me. Yes, yes. Okay, I need more coffee.
I've got it.
This is our planet, our seventh rock from the sun. the planet Uranus
Mhm.
around here. There's some galaxies you see in the background.
Wow.
Oh, those are stars. This is the characteristic diffraction pattern of the structure of the James Webb Telescope's optics. A lot of galaxies in the background.
Oh my God.
We get 6 points because of all those hexagon shapes.
That's part
not
of it, but
because
it's
of-
mainly the struts that are holding the secondary mirror.
Yeah.
Oh, okay.
Okay.
Why do the galaxies not show spikes?
They're extended objects. This is a point spread function for a point target.
Okay. Okay.
These are too faint to be resolved into the equivalent of points.
Okay.
And technically, there's a whole bunch of diffraction spikes coming out of all those things, but they're just
Right.
too faint to see.
Mhm.
So these are labeled with, they're fuzzy. This is Oberon. These are moons of Uranus.
It's
Oberon,
amazing.
I think it's Titania or
Yeah.
Umbriel, Ariel, Miranda. What's that?
Miranda.
Miranda.
Yeah, and I can't read the other ones.
There's Puck. There's Puck.
Yeah.
Yeah,
Puck.
yeah, there's Puck. Yeah.
He's in Midsummer Night's Dream.
Yep.
Yeah,
By
these are all
Mendelssohn.
Shakespearean characters.
Yeah.
Titania actually occulted a star back in November.
Mhm.
So that was pretty cool.
Now I get a question all the time at outreaches, and that when you look at the moons, at least the Galilean moons of Jupiter, they're all in one plane,
Mhm.
and
Yeah.
yet here they are not.
But they are mostly in a plane, but the plane, see how Uranus is tilted? So the rings are
Mhm.
Oh, okay, got it. Okay.
So if it's tilted, are we looking right down on its north or south pole?
North.
Yeah.
North
Yep.
Pole.
Mhm. Mhm.
North pole, and that's the rings around it.
Yeah.
Yep.
Mhm.
Okay, so that's the answer. Okay, good.
Look at that.
Here's a blow up. Here's the North Polar Cap, which is just
Wow.
a gigantostorm. It's not a sheet of ice because it doesn't have a solid. Well, it does have a solid surface in there. It's not like Jupiter and Saturn where there's no sharp surface. So, and then you can see the ring around it and some of the closer in planets, although they're not labeled in, or moons. It's not labeled in here.
So they're not testing their mirror, huh?
Yeah.
No, this is the same inside focus and outside focus.
Yeah.
So would it be safe to say, gentlemen, that when it was involved in the collision that turned it on its side, it took its moons with it and they just sort of flipped with it? Isn't that not possible with the gyroscopic?
It doesn't have to have been an actual hit. It could be a close pass that flipped it.
Okay.
And
And it
because
could have been while it was still forming.
yes,
But
could
let's say
have been a lot of things there, but if it was a direct hit of the mature planet, I don't think the moons would be arrayed so simply around it.
Hmm.
are they pretty much around its equator, even though it's
Yes,
tilted
they are.
90
Their
degrees?
plane is tilt too.
That would have had to have been a pretty big object that
Yeah.
flying by.
Could have been Jupiter.
Could
The
have been.
planets are not in the same positions that they were once a long time ago.
Yeah.
At least that's the theory I've read.
Yeah, but I think the models of the migration of Jupiter and Saturn don't allow for quite that much of an excursion.
Yeah.
Well, I hear there's
Well, I
even-
read a speculative article that big planets, big things like Jupiter form closer to the sun.
Yeah, and moved in and out.
Right.
Yeah, that's the Nice model.
Yeah. Okay.
Oh,
I don't know if it's true or not, but that's the way it is.
Well, it seems to explain a lot of the scattered objects that you see.
Yeah.
Yeah.
Did you
And
gentlemen-
Ron, we didn't
Good.
know this planet was there until 1781. You know, it's Herschel. Herschel found this. Yeah.
He
When
gave it
Mozart was
that-
still alive.
He gave us that embarrassing name that we changed over the
Oh,
years.
he wanted to call it King George's star.
Right.
Yes.
Well,
Whoa.
isn't Uranus or Uranus an ancient god?
Goddess of the heavens.
Oh, it's a goddess. Good
Yeah.
heavens.
Urania.
Why does
Oh,
the planet?
I'm sorry. That's Urania. Uranus was the father of Saturn or something like that.
Mm.
But did they say Uranus or did they say the one that embarrasses us?
I
the
think it
earlier?
was Uranos actually originally.
Mm.
With an O.
Yeah.
No.
OU.
Mm.
We're
Hmm.
looking at this at an angle because the planet seems to be against one side of the inside ring. I don't understand that. Why isn't it centered?
Well, the planet is centered. It's
Yeah.
just that blue thing there that you see.
Yeah.
This distance here is shorter than this distance here.
Hmm.
So we're not looking at exactly 90 degrees on this structure.
Yeah.
Okay.
So the
Oh.
pole is here slightly off. It's tilted to our right a little in this.
Yeah.
Part of the planet is blue and part of it is white.
Mm-hmm.
Yeah.
Oh, okay.
In those wavelengths, you know.
Yeah.
Mm.
Now, where, Jerry, where's the pole here? Is it where the
It's right there. Right
Oh,
there,
okay.
Tim.
I've completely it's kind of an illusion. If I look at it properly, I can understand that. I have it. I have the pole in my mind almost to the to the other where the blue and yellow meet.
Mm.
So
No.
yeah, right in there. And I thought this
No.
might have been an offset, but I get it. I see it now.
Okay.
Wow.
Okay.
Okay,
Moving
Tim,
on
take it
to
away.
The easiest constellation to see. And we have two
Colanders.
often overlooked star clusters in the Colander catalog, Colander 70 and Colander 69.
69. Yeah.
This
Tim,
is up here at the
Yeah.
top. This
Right.
is when you look at it, you get the impression with your naked eye that this is a single star. It's not, it's a star cluster.
Right.
And
Huh.
down here,
Tim,
ahead.
we showed we showed the folks this. Remember, it was centered on Misa, Lambda Orionis. So this is Colander 69. Remember, I took your 8-inch and I pointed at it, and you really
Right.
liked it.
Right. You see, you show a lot of stuff that's why I'm glad you're at the scope because
I like little telescopes.
yeah, it's really
they're easier to carry at our age.
Yeah.
Yeah, you got that right.
Okay, this is Colander 69.
Mm-hmm.
Oh,
Isn't that
see,
beautiful?
you can see the background nebulosity of hydrogen alpha hidden
Mhm.
away. This is not what you'll see on a full moon night. But
Mhm.
these three
No.
stars and these three here and these here make up the star cluster Colander 69.
And it's
There's
the
about a-
skinny Charlie Brown Christmas tree.
Yeah.
Yeah. Oh, that's right. It does look like a little Christmas
Yeah.
tree. This is about 100 stars. And it is one of the late stages of a star cluster. It has formed from gas. The stars have formed. They've blown the gas away. And now the stars are starting to drift off and lose their association with each other.
Mhm.
Hmm.
So remember, here's two bright stars and the three in between.
Mhm.
And that's just see what you see. Two bright stars and the three in between.
Okay.
There and
Okay.
there. So that's the whole cluster there.
Mhm.
And then Colander 70 is the entire belt of Orion, Alnitak, Alnilam, and Mintaka.
Mhm.
And that is shown here. This is actually a photograph. And it's been rotated. So it's, it's tipped about 60 degrees from the other one. But these bright stars and these other dim stars, these are part of this cluster. And so this is the cluster. The belt is really the brightest of the three stars of that cluster.
Yeah.
It's funny how many people see that in the sky when they
belt.
look up.
Oh, the bell. Yeah.
Yeah.
Yeah. All of those
Really-
Arabic words have to do with groin. All of those Al-Nitak, Al-Nilam, and Mintaka.
Or belt and girdle.
Yeah. Yeah.
Depends where your mind goes, you know.
Yeah. And then the
I've
other
heard
thing
of
is
those-
that, Tim, when you see this coming up, you're looking pretty much due east, when it comes up over the horizon, the
Yeah,
belt.
they're very close to the projection of the Earth's equator. And when I do the Orion Nebula, which is close to this region,
Mhm.
you see the geosynchronous satellites drift through the image
Mhm.
because
Wow.
you're tracking the nebula.
Yeah.
Wow. I can never remember the name of these three stars. I'm gonna have to do it about 60 times because that's the only reason I don't name them when I'm out at the outreaches.
Mhm.
Flashcards, read them every night before you go to sleep.
Yeah.
Yeah, exactly.
Well, Island Attack is you want to look at.
Oh, Bruce, hi.
Hi.
Hi, Bruce.
I fell asleep. Anyway, yeah, Island Attack is something you want to look at because the Flame Nebula is very close to that.
Mhm.
Mm.
Bruce Murdoch has joined us, ladies and gentlemen. Another grandpa. Stupid question time. Star clusters, are they pretty much the same thing as an ultimate binary, trinary? In other words, are they orbiting each other?
No, not really.
So a binary isn't a two-star cluster.
Well, you could think of
Right.
it that way. It's just
Could
more
be.
tightly bound than most of these open
Yeah.
clusters are.
Okay, but that one you showed a moment ago is only 6 or 7 stars.
That's how it looks from Earth. Any one of these stars, like Alnitak, Alnilam, or Mintaka, could be multiple star systems. I don't think they are, but it would, if they were, they would look just the same here and be part of this cluster. So you can't tell from this scale of telescopic view. But
And there were about 100 stars in that other cluster, Ron.
yeah,
But my understanding has been that most of the stars, more than half of them, are multiples.
Yes.
So
Yeah.
the ultimate multiple would give you a whole cluster then, wouldn't it?
That would be like a globular cluster.
yeah, if they're that tight together, it would be a globular cluster where they all sort of chaotically orbit each other or a common center.
Is the red background part of Bernard's Loop?
Yes.
The red background is emission nebula, hydrogen.
That whole molecular complex up there around Orion, that Barnard's
Yeah.
Loop and all of this stuff is gas.
Yeah. So that's right where his head would be.
Yeah.
Right, his head.
So the three, okay, you missed. Can you go back to that picture and just settle one thing for me as I lose my voice? No, that's not the one. The one with the different stars located. Yeah. Are the three in the middle, the little ones that are lined up, is that the belt?
No.
Oh,
No.
no.
This
is
whole
at the
thing is the head of
Orion.
Orion.
Yeah,
Yeah,
see,
it's right at the head, way up there.
these are the three stars that were lined up in the middle between these stars. And you see that this is a blow up of this part up here, which is the head of the Orion.
Oh, I see.
And
The belt's down
the
below it.
belt is way down here.
Mhm.
Okay. But that's all part of the constellation, right?
Yes.
Yes.
Brian.
And then the
Gotcha.
sword is down below there, below the belt,
Yeah.
where 42 is.
When I show M42 to people at night, I very often get the question you just got, well, because there are 3 stars in a row that are quite near it.
Yeah.
And is that the belt? I said, no, we're way zoomed in. The belt is up here,
Yeah.
Yeah,
That's the sword. That's Orion's
I
sword.
know it is.
Yeah,
Right,
no, well,
right.
Tom, I think he's referring to when you zoom in on the Orion Nebula, there's the trapezium, and then off to one side of it, there are 3 stars in a line too.
Oh, okay.
Yeah. It throws people off.
Well,
Okay.
remember my grandpa pointing up to those 3 stars in the belt saying, son, that's the 3 sisters. And 75 years later, they have not moved at all.
They have, you just haven't noticed.
Yeah, he needed
Yeah.
a bigger scope.
Okay, guys. Calendar catalog. All right. 471.
Colander catalog, I called it a lesser catalog, but no.
Oh,
no
don't
pun-
you dare.
No slight intent.
It's
Colander
great for
catalog.
little scopes. It's just so great for little scopes. These things are pretty bright.
Yeah. Catalog of 471 open clusters compiled by the Swedish astronomer Per Colander,
Mhm.
published in 1931 as an appendix to Colander's paper. It was also, these people developed specialized catalogs like this
Mhm.
because they don't want to just add on to the NGC, the new general catalog, which is no longer new. It was formulated in the 70s or something.
1885, wasn't it?
Yeah, somewhere around there.
Yeah. So yeah,
Well, that's a
Colander did
continuation
just
of first William Herschel's catalog, and then
Yeah.
John Herschel's
Mhm.
adding to the catalog, and then finally Draper or somebody, they just kept adding and adding.
Yeah.
Yeah.
Yeah, I think even, the coat hanger Chuck, isn't that a colander?
Yes.
Rockies cluster?
Oh, yeah.
There's a ton of these things, and they're really neat little scopes.
That's probably classified under an asterism.
Yeah, yeah.
What do you suppose Colin did just for his Scandinavian buddies, or it's got to
He
be
was a
item?
Swede.
Oh,
Yeah,
okay.
he was Swedish. Yeah.
Yeah.
These open clusters used to be called galactic clusters because they seem to be concentrated in the plane of the galaxy. And he was studying their distribution here. So that's why he made his own separate catalog, so you could just pull out these things.
Yeah.
A lot of them are probably NGC objects also.
Could be.
Well, everything's
Yeah, a lot of them get double entry. Okay. This is
new comet in town, I think.
It's not a new comet.
It's not?
This is a new way to process comets. This is a periodic comet 12P Pons Brooks. It's a 70-year period, similar to Halley's Comet. And here it was imaged on December 10 of this year, 2023, as it slowly moved past Vega, which is the bright star you see there. Later next spring, it will round the sun and be a bit closer to Earth and a bit brighter. But this was posted on Facebook by Adam Block, who was pushing a new comet processing on comet tracked data. So it's difficult to take pictures of comets because the comet is moving with respect to the star background. So if you put your scope on the comet and take a long exposure, then all the stars will be streaks. And he has developed a technique to take pictures of the comet by following the comet, but processing so that the stars stay these small point-like things. So it gives this nice image. And so he's selling this process. You know, you get sign up for his school and learn it. Yeah. He's probably the best astro image processor I know of.
Yeah, he probably does this, Jerry, for up Mount Lemmon, huh? Above
Yeah, part of the observatory system at the University of Arizona.
Yeah.
And this is a close-up picture of that, showing the nucleus, coma, bow shock, tail. Tail goes all the way down.
Wow.
Very excellent processing. High resolution, you can see these two stars just resolved.
Well, depending on how old the universe is, what billions of years, there's got to be long since depleted comets that are just pretty much dry asteroids now, having gone around the sun jillions of times. They finally lose all their gas and ice, don't they? I would imagine.
Yep, exactly.
Do we see them as comets?
No, they've lost all their fuzz. They don't have hair anymore.
We only see them because of the fuzz. Interesting. Okay.
Well,
you see them as asteroids now.
Yeah.
Oh.
Phaethon, the asteroid that causes the Geminid shower that we just had, is like that.
Wow.
So H2O doesn't have a friend in the sun at all. It doesn't exist close to the sun. There's no water.
It exists as molecules in this region of the solar system.
Yeah, further out. The closer it doesn't exist, or it's separated into oxygen and hydrogen atoms. They don't exist as. Never mind. Go ahead. This is fascinating.
Okay, these are successive simulations of the interaction of the Andromeda galaxy shown here and our Milky Way galaxy shown here. And over a certain time, this one will get closer. It's going to interact with, there's a high probability it's going to interact with our galaxy, but it depends strongly on the lateral motion of the Andromeda galaxy in our skies, which is very hard to measure. But for this simulation, they measured the proper motion of several thousand stars in the Andromeda galaxy, and averaged their proper motion with respect to our reference frame in our Milky Way, and they took that as the lateral displacement or motion of the whole Andromeda galaxy. And with that, it looks like it's going to be a hit. So these are, and this is what it will look like as they start interacting, Andromeda is being slightly distorted. And then we're in a real mess here with gravity interacting between the two galaxies and getting very intense. These are actual simulations of these billions of stars as particles. And here they're starting to coalesce into a single structure now.
We're going to merge.
They're merging. There's the two cores. They have now lost most of their spiral nature. They're now more like, what are those things? Spherical galaxies, irregular. And here's the elliptical, thank you. And here's the final result. The simulation shows that we have a high probability of ending up in an elliptical galaxy. So the time frames involved.
No more arms.
Yeah.
Yeah, no more arms for us.
And a lot of the gas and dust gets made into stars.
Yeah, it'll be a lot of star formation. There's a chance that M33 may also be a participant in this collision.
Wow.
Because it's gravitationally bound to us.
Boy, then what do you call it? Pin milkometa?
Milkometa.
Milkometa wheel?
Yeah, milkometa.
Well, but you got to add in the pinwheel.
Oh, yeah.
Okay, now there's one figure I'm missing, gentlemen. The Andromeda is now what, 2.5 billion light years away, or million?
Million.
Million with an M. Okay, and it's moving at us at 20 miles a second or so. How many years are we talking about? How many billions?
About 4 billion.
Yeah.
Yes. There is a 12% chance that the solar system will be ejected from the new galaxy during the collision, so that we will not be in the resulting elliptical galaxy. We will be in intergalactic space between galaxies. But there's also a 50% chance that in the merged galaxy, the solar system will be swept out 3 times farther from the new galactic core than it is at current distance.
Yeah. Hey, Ron, I was just going to say, imagine, many billions of years ago, suppose there were civilizations in a galaxy and they were just wiped out by an intruder, Just something to think about, that's all.
Well, so 12% chance that we'll get thrown out. So the odds are on our side that we'll stay in the family.
Yeah.
Could that transition us into the voids we're going to be talking about? Is that where we might get tossed into a void?
Well, that's the 12% is tossed. No, not a void like we're about to talk to.
Right. Those are
and
huge.
we better move to that. So, but by the
Ron,
time
around this time, 4 billion years in the future, we're going to be having problems with the sun anyway.
Yeah, life on Earth will be a long time gone because the sun will be 30 to 40% hotter than it is now. It will have boiled the oceans dry for us.
And probably swallowed Mercury and maybe Venus, if not us.
Yeah. And maybe the Earth. This is an artist's rendition of a void in a network of galaxies. This is not a photograph.
Reminds me of an old rock and roll show at the Earl Warren, the stuff they used to throw on the screen behind the rock star.
Yeah, I remember the 60s.
Yeah.
So the hot topic in astro and cosmology right now is voids.
Voids.
That is these vast, large, empty spaces. And they're just right now, they're at a stage of cataloging these voids. And there are about 6,500 voids that have been mapped in space. This is a summary page from a Scientific American article in the January 1, 2024 issue.
It's great. Yeah, Jerry, great article. I just got mine a few days ago. It's really good. Yeah.
And so these voids are vast holes that are up to, let's see, the time light took to travel. So this is, we've mapped them and projected on, here. So
We're
these
talking
are
about half a billion light years?
Yeah.
Giga year. Let's see the scales on the next one, I think.
Okay.
It's also in that estimated void side with the dots there.
But are they usually shaped like spheres?
They're roughly
No, not
spherical,
really.
apparently.
Yeah.
They're just
It's
voids.
a
They
good
may
way
not
to
be
model
perfect.
them.
Right.
Yeah, this is unbelievable detail. I mean, when John Huckra and Margaret Geller were doing this stuff in the 70s, there was no detail like this that I remember.
No,
Yeah.
Yeah.
they're hard to figure out.
Yeah.
Here, this is where we are. You are
Mhm.
here, and me too. These lines go out 1 gig a year. That's a billion years. 2, 4, 5, 6, 7, and out to the visible limit of 13.8 gigayears.
Mhm.
And so you see these things are clustered down here.
Yeah.
And this is the southern from Earth. This is in the southern hemisphere.
Mhm.
There's the Eridanus supervoid,
Mhm.
Pegasus void, Fornax void, and going back to the northern hemisphere,
Mhm.
they have these giant voids. This is the Buddha's void, referred to as the Great Nothing. It is a supervoid
Yeah.
comprising multiple subvoids. So
Yeah.
they're not just a sphere of nothing, but they're very low density to no density. There's no visible things there. There might be a lot of dark matter there, but there's no visible. These are visible voids.
Yeah. Hey, Tim.
Yeah.
Yeah, this is how somebody, in Brooklyn would try to pronounce Verd.
Oh, Ferd.
Yeah, my mother used to
bird.
recite a little ditty.
Yeah.
A toity doity toipo boyd sitting on the coib, just a choiping and a boiping and eating doity worms.
It's pretty good.
Well, that was only part of it. I
This
didn't
is,
say-
there's this Hubble tension about the Hubble parameter. And
Mhm.
one of the proposed solutions is that we're kind of in one of these big voids, and that affects what we see as the expansion rate because there's
Right.
gravity warping the space-time.
Huh.
Well, they have the universe laid out as a big cobweb, all the strands of galaxies.
Mhm.
Yeah.
These would be areas in between the strands, wouldn't they?
Right.
That's exactly right. That's what this thing represents. See,
Oh,
this
those are-
represents the strands, the neural net of the
Galaxy.
universe, and then there's these big voids like this in it.
Yeah. Yeah, when
Well,
Huckra and Geller,
Is the source of this data, is it radio telescopes or what?
All
source
kinds
of
of
what?
data.
yeah.
Huh.
I was just gonna say, when Huckra and Geller were studying this stuff early on, they had this figure of a man. Do you remember that,
Hmm.
Jerry? It was like a man and then all these holes, I forget, it's like a stick man or something.
Oh, there it is. A Sloan Digital Sky Survey. Okay.
Yeah.
Okay.
So they're looking at apparent brightness from Earth. They're just giving us a scale of
Mhm.
the legend for these things. So these are visible objects that are mapped.
Mhm.
There's no reason they shouldn't be mapping them in radio waves.
This is fascinating. I had no idea this existed.
But they found a little scattering of little pinpricks of galaxies in the middle of some of these voids. They somehow see 6 or 7 when there's, in other places there's thousands of galaxies.
Mhm.
Can they see these little galaxies? Do they look like stars?
If they're close, I
Yeah.
mean, they're faint.
Wonder what it'd be like to be on a planet in one of those galaxies. Would everything look normal?
We may be in one of those. We may be in one of those, Ron.
Yeah.
Yeah.
You're kidding.
So let me tell you why they're doing this. Just reading the top sentence up there, it says regions of relatively empty space called cosmic voids are everywhere in the universe, and scientists believe studying their size, shape, and spread across the universe or the cosmos could help them understand dark matter, dark energy, and other big mysteries.
Mm.
So this is because we've just discovered this new feature, and now we're trying to see what it will tell us about the cosmos. But there's no speculation yet on tying it directly to dark energy or that yet. They're
Will it
starting
explain my
correlation.
memory too?
What's that?
Will it explain my memory too?
Yeah.
Hold that thought for as long as you can.
Okay, it's done.
But there's some theories, are there not? Especially among the quantum theorists, that matter pops out of nothing. Why couldn't these
Oh
voids?
no, that's established. That's experimentally verified.
Mhm.
Ooh.
Okay, and the
They're
voids
called
don't have.
they're called virtual particles. They pop out in pairs and then they pop back in pairs.
Mhm.
While they're in this universe, because they're virtual, they do not obey conservation of energy laws. They just are there and then they're gone very quickly.
Well, you got Hawking radiation there that one of them just doesn't, goes back in.
Hawking radiation near a black hole, that separates them. One falls in before they can recombine, and the other one then takes the energy and goes out.
But most of the stuff around us that we're made of in our galaxy or in our solar system came from the Big Bang, or are we half recent popped out and half Big Bang original material?
Everything in our universe came from the Big Bang.
Yeah, and the particles that come and go in the void and occasionally persist. Like you could have high energy gamma rays that whack into each other and end up creating a particle, but that's really, really, really tiny in the big scheme of things.
Okay, but the dark matter we can't see, but we know it's out there, and therefore it may fill the voids, all dark, invisible. It's black to us.
It's there because of its gravity.
Yeah, and it wouldn't if it were in the voids and there was a lot of it, it would tend to have attracted normal matter. Right. So it's more likely concentrated in the strands.
Where's the antimatter? Is
gone?
Do they know?
That's a big question.
Is it?
Yeah, where's the antimatter?
That's another Monday show, Jerry. Antimatter and matter.
No, there's no answer to it. I can't answer that question.
Jerry, is it possible? They're trying to understand, this may help them to understand dark matter, dark energy. And Chuck, when you were saying we might be in one of these voids, is that maybe part of the reason we might not be able to understand the dark energy and we might not be able to detect it because we're in it?
Well, the dark energy is this expansion, this Hubble parameter. And there's this Hubble parameter, tension, they call it, because they're getting different measurements. And that might be because we're in a void.
I think Tim meant to say dark matter.
No, dark energy.
Dark energy, okay.
Dark energy is what's driving the expansion.
Yeah, just the opposite of what dark matter does. It brings gravity.
Yeah.
And the whole key to the thing are black holes. They're the secret to everything, aren't they? We might be in one of those too.
Wasn't there a theory about that, Chuck, at one time? That it's possible we were in a black hole?
Yeah, well, that's just because we don't know what the heck's going on inside a black hole.
Yeah.
Well, can't wait to talk to that columnist. He's going to talk to us in March.
I didn't realize that the dark energy is forcing everything out. Dark matter is forcing it in.
That is a speculation.
Yeah.
Well,
that's interesting. Very interesting.
Gentlemen, we've overstayed our time and it's been awesome. And I think it's time to go break our toys that we all got for Christmas. And I guess we're going to meet here on New Year's Day in a week, with or without our Santa hats.
Yep.
All right.
With the Nose Parade.
All right, you got a date, gentlemen, and we'll be seeing, I guess, you on the star parties to come and different events happening at the beautiful Museum of Natural History. This is the SBAU Astro Hour, wishing you happy holidays, everybody. And watch us and see us on YouTube and join us again next Monday morning for
Happy holidays, everybody.
Bye, everybody.
All right, thanks.